Hello, this is question 8 on June 2019, paper 2 from AQA. Teresa bought a house on the 2nd of January in 1970 for £8,000. The house was valued by a local estate agent on the same date every 10 years up to 2010. And the values are here, in this table. The valuation price of the house can be modeled by this equation, where V pounds is the valuation price T years after 1970, and P and Q are constants. We have to show that this expression here can be written this way. So the only thing that we have to do here is to take logs. They're using logs to the base 10, so let's go into use that. If we take logs in both sides, we have log to the base 10. V is log to the base 10, P, Q, T. And then we are going to use the properties of the logs. So first part is the same, but then log of a product is the sum of the logs. So I'm going to write log to the base 10, P plus log to the base 10, Q to the power of T. And when I have an exponent, remember it can go to the front of the log. So there we have our expression. So 10 P log to the base 10, P plus T, log to the base 10, Q. Yeah, that's what we have to prove. That's the expression, and that's the first part. And then the values in the table of log V against T have been plotted, and a line of best fit has been drawn in the graph below. So we have the values of T, which are the years since 1970, and the values of the log, and then they plot the points in a scattergram diagram, and they draw a line of best fit. Using the given line of best fit, find estimates for the values of P and Q. Give your answer to 3 significant figures. So we are going to use this line of best fit, and we are going to write the equation. So we know the y-intercept. The y-intercept is just midpoint between 3.8 and 4, so it's going to be 3.9. Y-intercept is 3.9. And the gradient is the gradient of the line. So we can get 2 points in the line, or we can use the values that we have here. So the values, the change in y is going to be 5.31 minus 3.90 and divided by 40 minus 0. Yeah, we can use that to find the gradient. So the gradient is going to be 5.31 minus 3.90 divided by 40 minus 0. And this is 0.03525. Yeah, that means that we can write the line as y equals gradient 0.035. I'm going to write just that. Although in the calculator I'm going to use, well, it doesn't matter because we are approximating the gradient anyway. Yeah, so we can use perfectly this value. Gradient times x plus y-intercept. And we are going to use, instead of x and y, we are going to use the actual x and y. So y is my log v and x is my t. So I'm going to write the line as log to the base 10 v is 0.035 t plus 3.9. Yeah, this expression comes from this one, or is equivalent to this one that we had here. Yeah. So we are going to compare both expressions, and we know if you compare this one with the other one, you see that the number that is multiplying t is the gradient, and this number alone is the y-intercept. So log p is the y-intercept. This is going to be log p. The y-intercept is log p. And the number that was multiplying the t is log q. And with this, I'm going to find both values. So if log p is 3.9, that means that p is 10 to the power of 3.9. You just do that with the calculator and you get 7943.28. Yeah, they ask round to 3 significant figures. So that means that P to 3 significant figures is 7,940. yeah, to 3 significant figures. And for Q, I'm going to do the same. So log Q, log to the base 10 of Q is 0.035, which means that Q is 10 to the power of 0.035. You do this with a calculator and you get 1.08 for something else. Then Q, round to three significant figures, is 1.08. Yeah. So these are my values for P and Q. Next thing, they say, determine the year in which Teresa's house will first be worth £500,000. So we want to know when V is £500,000. Yeah, B is completely in pounds, not in thousands of pounds or something like that. Always check that, because that's quite common that they say, for example, that V is not the pounds but thousands of pounds. So be careful. So we have an expression. Thanks to find P and Q, we can write an expression for V. It comes from here. So V is P times Q to the power of T. So we are going to use that expression there. So V, we have an equation for V. V is P, and P was 7,940 times Q, that was 108 to the power of T. So we want to know when this is greater than 500,000. So we are going to make it equal to 500,000 to see when that happens. Yeah. So just dividing by 7,940, we have 1.08 to the power of T is going to be equal to this value. No, 1 less 0. Divided by 397, which means we can take logs here, and we can take logs in any base, but if you take logs to the base of 1.08, yeah, so taking logs, it doesn't matter because you're going to get the same answer. So if you take logs in this base to this base, we have, it's just faster, I think, divided by 397. So left hand side is just T, and then we do this with the calculator, and it doesn't matter the base because you can do with the calculator, you can take logs to any base. So this value is 53.029 something else. This added to 1970, yeah, so 53.8 years after 1970 is 2023.829, which means if you think about rounding, you will round up. But think that this is happening, so the house reaches half a million at one point in 2023. Yeah, so almost at the end of 2023. But it happens in 2023, and that's what they're asking you. Determine the year in which the house gets that price. So it will happen in 2023, at the very end, but in 2023. Yeah, don't round up. So always, when you are rounding these type of values, think if it makes sense to round to the nearest number, or because of the question, it makes sense to round something different. Yeah, like this is the case on this one. And then explain whether your answer to part C is likely to be reliable. So it is 2 marks. So we are going to give a couple of reasons. One could be more mathematical one. So if you think that your graph or your values are up to 40 years after 1970, yeah? So up to 2010, no? And we are talking about 2023, so we are extrapolating. And remember that every time you extrapolate, you don't know what is happening after. So things can change a lot after 2010, yeah? So one of the things that you can say is that is extrapolation, and extrapolation is not very reliable, no? So we are extrapolating because we are out of the interval after 2010, so not very reliable. And the other option It should be something more according to the context of the question. So reliable. You could say something like the market changes constantly. So the increase won't be constant, or the price increase won't be constant. Won't be constant. Something like that. You know, the market change, price changes, or they can, I don't know, make a big motorway in the front door, and the house will decrease the price, or you can do an extension and it will increase the price, or a swimming pool. So there are many things that will affect the price of the house, so it's unlikely to be completely constant. Won't be consistent or constant, I would say. Constant. They are just looking for something related to the context of the question that makes a bit of sense. You don't have to have a particular answer. Yeah, and that's all with this exam question.